Hello class. Okay, this is a review of Test 1 of Spring 2016 for the Microeconomic Principles class. So let's get underway. So here's the answer key. This is the first problem. So you can pause it there and get all the answers if you need them. Now I want to show you how to work it. So to find the equilibrium price and quantity, you just set the quantity demanded equal to quantity supplied, like we've done many times. You get the equilibrium price as 400. Then from the equilibrium price, you can plug it in either to the demand equation or the supply equation, and you can solve for the equilibrium quantity, which works out to be 650. Then it asks, given the equations, how much would people want if the government provides it for free? That's going to come from the demand curve. And if the government provides it for free, this will be 0, so the quantity demanded will be 850. That's this number down here. Then it asks, given the equations, how high could the price go before consumers bought nothing? Again, this comes from the demand curve, and we're looking for a price now where consumers buy nothing. So setting this equal to 0 and solving for P, you find this number right here, 1700. That's the highest price. And then finally, consumers buy nothing. Then it asks, given the equations, how high can the price go before producers decide to enter the market? So this is about the supply curve, and it wants to know how high does this price need to get before the quantity supplied goes from 0 to some number. Visually, it's this place right here. You set quantity supplied equal to 0, set this thing equal to 0 and solve for P, and you'll find that it's 75. Then it asks you to find the point elasticity of demand. You just use the formula, 1 over the slope times P over Q. It's actually kind of easy because thanks to Alfred Marshall, 1 over the slope turns out to be the coefficient on the P variable from the demand curve. So it's just minus 5 times the P value, which was 400, divided by the Q value, which was 650. And it works out to be minus 4 over 13, or if you did it in your calculator, minus 0.307. Then it asks you to interpret that, and of course, ignoring the sign, it's less than 1, so it's inelastic. Next, suppose the government set a price ceiling at 350. Well, 350 is below 400. It's a price ceiling, so the price cannot go above it. It will be binding. The quantity demanded will be 675, found from the demand equation by just putting the 350 in there. The quantity supplied will be 550. Found from the supply equation by putting 350 in there, and the difference of course is a shortage of 125. Finally, it asks to calculate arc elasticity between PE and the price of 350. So they're asking you to calculate arc elasticity from this price right here over to this price right there, and you just use the arc formula. You arbitrarily assign one of these to be 0.1 and the other to be 0.2. So this would be Q2 minus Q1 over Q2 plus Q1 all over P2 minus P1 over P2 plus P1, and you work that out, and it works out to be, if you did it in your calculator, minus 0.283, or if you just tried to simplify the ratio, I got minus 15 over 53. So those were 2 points each. Next question was kind of short answer. What's the difference between unit neutral elasticity and relative elasticity? Unit neutral elasticity comes from this formula here, where of course since this percentage changes there's no units, and relative elasticity just compares slopes, where the units of course would affect the slope that you find. Then list the factors of production. They're land, labor, capital, entrepreneurial ability. And the other factor that's important in determining the production possibilities curve is technology. The tragedy of the commons is in the book. I forget if it's in chapter 2. You know what? I think it might be in 6. So basically, there's 2 problems with the tragedy of the common. One is that no one has ownership or feels responsible for doing things, and the other problem is that people will overutilize the commons. So for example, if there's a common grazing land, nobody owns it, then all the farmers in the area will let their cows or their sheep graze there because no one has a vested interest in maintaining it. A Peruvian tax is a per unit tax. It's a per unit tax applied where there's a market failure. And Professor Percuse said if you just set the tax equal to the magnitude of the negative externality, it would be a way of internalizing the externality. Then this was a kind of a discussion piece. So the point I was trying to make is a good is defined to be something that when you consume it brings you utility, but value is determined at the margin, right? The value of something comes from its last use, not its first use. So if a thing is truly a free good, at the margin it has no value. So technically it's not a good in the sense that we can see it. Then own price elasticity is always negative, but cross price elasticity might be negative or positive. Which goods have negative cross price elasticities and which goods have positive ones? Okay, so cross price elasticity would be the percentage change in the sales of, say, good X divided by the percentage change in the price of some other good, say good Y. So complements would have negative cross price elasticities because when the price of a complement goes up, say like hot dogs and hot dog buns, they're complementary. When the price of hot dogs goes up, the sales of hot dog buns would go down, so it would be negative. Then substitutes have a positive cross price elasticity because hot dogs and hamburgers would be substitutes. So if the price of hot dogs went up, the sales of hamburgers would rise. Okay, so Roman numeral 3, we spent some time discussing the difference between the concepts of shortage and scarcity. Shortage is defined on page 94. I defined it in class as a market disequilibrium where the quantity demanded exceeds the quantity supplied. Scarcity is defined on page 6, and I defined it as a fact of life. It comes from nature. We live in a world of scarce resources. Then I've asked you to draw out an example of scarcity and shortage. Actually, to get full credit for an example of scarcity, you just had to draw a supply and demand curve. It doesn't really matter if the price is high or low, although it seems logical that you would draw it kind of high. But really, anything that we have to pay for, even if it's relatively inexpensive, would be scarce. So this was easy. A shortage, on the other hand, to get full credit, you need to show me a binding price ceiling where the quantity demanded exceeds the quantity supplied. Then in this part, let X and Y be substitutes, let X and Z be complementary, show what happens in each market if the supply curve of X shifts left. So it was kind of weird. I told you that the supply curve of X shift left, but some of you still got that wrong. Then if X and Y are substitutes, if the price of X goes up, which it's done, X has gone up, then people will buy more of good Y because it's a substitute. So the demand curve for good Y would shift out to the right. And if X and Z are complementary and the price of X goes up, people will buy less Z, so it will shift down. Alright, that was Roman numeral 3. Then Roman numeral 4 was just these supply and demand exercises. So if the winter crop of Florida oranges comes in, and this is the supply and demand for oranges, then all that happens is that the supply curve is increased, the demand curve stays the same, quantity supplied and quantity demanded both increase, and the price falls. Then the second one says, have you seen these boxes in the grocery stores that need everything to make an orange Julius? This is a drink that uses lots of oranges. What happens in the market for this product? Well, the price of oranges has gone down, so logically people would buy more of those orange Julius mixes, so the demand curve increases, supply curve stays the same, quantity demanded and quantity supplied both increase, and the price increases. And then it says what happens in the market for other kinds of fruit in the grocery store that compete with oranges. So these would be substitutes for oranges, and since oranges have gotten cheaper, the demand curve for those things would fall. Supply curve would stay the same. Quantity demanded and quantity supplied would both decrease, and the price would decrease. And then the fourth one, it says, suppose orange growers lobby the government to prevent the importation of oranges from Mexico. What would happen in the market for oranges sold in the United States? So this is just oranges, not where they come from, but just all the oranges sold there. So if we restrict Mexican oranges, the supply curve will shift back to the left. The prices of oranges will go up. People will buy fewer oranges, so the quantity demanded and the quantity supplied will both decrease, and the demand curve for oranges will stay the same. Then given number 4, that is, we restrict the importation of oranges from Mexico, what would happen in the market for oranges grown in Florida and California? Well, they're not restricted. They're a substitute for Mexican oranges, so the demand curve would go up, supply curve would stay the same, quantity demanded and quantity supplied would both increase, and the price would increase. So those little squares were 1 point each. Then in Roman numeral 5, this was another algebra problem. So the first part is just exactly like Roman numeral 1. You just set quantity demanded equal to quantity supplied. I don't think anybody missed this, but then some people got confused down here. Now, after the tax is imposed, what? How do you find the price consumers pay? Well, all it is the new equilibrium from the new supply curve with the demand curve. So you would just do it like this. The quantity demanded equals the quantity supplied tax. Just like you did it before, quantity demanded equals quantity supplied. You're just using a different equation. You're using this equation right here, right? Solving that you get the new equilibrium is, where did I do it? Oh, the new equilibrium is 234, so that works out to be the price consumers pay. The new equilibrium quantity works out to be 1132. I don't think I asked for that, but you need it to get the other answers. Let's see. The price producers get, yeah, you need it for that. So if you have this number, the price producers get is right here, and the way you find it is you have this number, 1132. You have this dot right here that's on the original supply equation. So if you just put 1132 in here and solve for the price that would have made that happen, it works out to be 222. You can see my work right here. So then, what else have I asked you? From that you can figure that the unit tax was $12 because from here to here is 12. Unit tax is 12, and the tax revenue generated would be $12 times the number of units sold. So it would be 12 times this number right here. That works out to be 13,584. Find the point elasticity after the tax. So that's this point right here, and you would find it just like we did before. Elasticity is 1 over the slope times P over Q. 1 over the slope is -2 because it comes from the coefficient on the P variable on the demand curve. And then the P value is 234 and the Q value is 1132. And that works out to be -0.4134. Okay, so interpret without the math what is meant by your answers. So since this is less than 1, ignoring the sign, it is inelastic. This was a little harder. If we raise the per unit tax by 10%, we should expect sales to do what? So you have to think about this number right here in the definition. So the definition is percentage change in Q over percentage change in P. And we know the answer is 0.4134, right? And we can make it a ratio just like this by putting it over 1. But now I need to get the denominator, percentage change in P, not to be 1%, but I need it to be 10%. So if I multiply both sides by 10, this becomes -4.134 over 10. And so now it is very helpful like this. If we raise the per unit tax by 10%, right, we should expect sales to fall by what percent? So we should expect sales to fall by 4.13%. Then you have this bonus question. You know the definitional formula for own price elasticity. It's this thing right here, percentage change in Q over percentage change in P. What would be the definitional formula for cross price elasticity? So this is a bonus question. So in cross price elasticity, you're looking for the percentage change in the sales of some good, I'm just calling it good X, with respect to the percentage change in the price of some other good called good Y. So if you could write that, or if you wrote it in the arc form, which some of you did, you got 5 points bonus. Okay, that's the whole test, and I'm sorry you didn't do better, but there's going to be a bonus test next class, so hopefully this video review will help you. Alright, good luck.